What does CERN's Large Hadron Collider have to do with financial markets? I will explain to you how particle physics helps find anomalies in financial markets so we can better protect them against manipulation. Algorithms are increasingly taking over human trading activity on financial markets such as stocks, futures and options markets. They act much faster and trade automatically, and sometimes their actions are not even perceivable by the human eye. These changes increased data size tremendously and allowed new types of manipulation to arise. For example, the New York Stock Exchange produces about 2 terabytes of data per day, consisting of 75 billion market events. This is a challenge for regulators and researchers looking for anomalies, because where do you start looking when there is so much data? But what does all of this have to do with particle physics? There are similarities between CERN's Large Hadron Collider and high-speed trading on financial markets. In the Large Hadron Collider, 2 particle beams are made to collide. About 1 billion collisions happen per second, and this produces huge amounts of data. Usually, the data shows no anomalies, but when they do, this may lead to new, groundbreaking insights for physicists. We can draw an analogy between the particle beams and high-speed trading in financial markets. We have one beam of buyers and one beam of sellers, and when these beams collide, we have a transaction. But different from the particle beams is that anomalies, in our case, do not only occur during the collision of buyers and sellers, but also during the traveling. So for example, when buyers and sellers place orders, cancel orders and modify their orders. Applying particle physics to financial data opens up a whole new world, and it makes us able to see behaviors and patterns that we did not see before. Wageningen University and Research, Cormac and CERN have started a collaboration in 2019 to apply particle physics to financial market data. Our goal is to identify anomalies that might harm the market to better protect these markets. Let's get back to the trade floor. One type of manipulation is spoofing. With spoofing, a trader intentionally adds a large order that they never intend to actually become a trade. They only place the order to introduce false information in the market, because they want to manipulate the price. In our research project, we look at limit order book data to see where the anomalies have occurred. A limit order book is much like a marketplace where buyers and sellers come together, and we see all different prices and volumes people want to buy or sell for. The traditional way of looking at this type of data is by taking snapshots, and you can compare taking snapshots as a picture. So every second or every minute you take a picture and look at what the state of the market was at that moment. But our challenge is that traders and manipulation often happens in nanoseconds, and you cannot see what happens with pictures. So that is why we developed a new visualization method with the help of particle physics. Now we are able to see every single action happening in the market, much like a video instead of a picture. And we are able to see the complete story of what is happening. So for example, sometimes in a single millisecond, 20 things happen. An order gets added, a price gets moved, volume gets removed from the market. And instead of taking a picture and seeing the end result of all these 20 different actions, we see every single action taking place, giving us all the information we need. In this case, we visualize a single spoofing case that happened between 2008 and 2016, which was identified by an American regulator. As you can clearly see by the bright yellow bars, 6 spoof orders were placed on the buy side. These orders were each worth $34.8 million and were placed and removed from the market within 5.2 seconds. Because of these identified manipulations, traders have lost $311 million between 2008 and 2016. These were only the identified manipulations, so we expect actual losses to be even higher. These visualizations help us better understand spoofing. We can zoom into specific events, add more aspects, and truly understand how the market responds to certain events. For example, we found out that spoofing is not only used to manipulate the price, but also to attract more participants to the market. Our research contributes to a fairer and better functioning of financial markets and is valuable for all stakeholders involved, such as regulators, exchanges, and market participants. In the future, we hope we can identify anomalies happening real time, so we can develop an early warning system. Would you like to receive updates on how we help uncovering manipulation in financial markets? Visit our website and sign up.